Just a quick follow-up to my recent video looking at Bobby Shafto's footage from Puget Sound. I thought it might be useful to include a demonstration, not include at this point, follow it with, append a demonstration of the plotting software to answer a couple of things. Answer three things. One is, no, perspective isn't straight lines, but I've already covered that in another video. As you can see across the top here, those lines across the top aren't straight across the top. Why not? Because that far in front of you and off to your right is farther away. So the same height up is at a greater distance, so it subtends a smaller angle. Another one was to say, does it actually work? Obviously I checked that it works, but it occurred to me I didn't include that in any video about it that I can recall. And the third is, why use mountains? Why not look at Brown Point? Whatever the next one is, Point Robinson. This image on screen is a pair of plots. It's the plots of the flat and geometric, not bothering with refraction at all, over about 3/4 of a mile. 40 degrees north, 98 degrees west. I think that's somewhere in Mexico. Looking north, exactly north, there's a cross, a giant black cross down here in the middle with a couple of blobs near it, which is eye level and azimuth. And these are sets of points that are at longitudes. Over on the right, 97.9997, then 97.9998, 97.9999, 98, 98.0001 degrees west. And latitudes are way up at the top, 48.001 degrees north, and then 48.002, 003, 004, 005, down to 011, which is about 1/4 of a mile. Sorry, about 3/4 of a mile. Brain. Not quite shaking this cold yet, apparently still short of oxygen. The flat calculation is in blue, the globe calculation is in green, and as you can see, even at the very top of this, they don't line up, which may be something to do with the way I've calculated the elliptical stuff and tilted the camera. This is as if the camera is tilted slightly too far back on the globe one relative to the flat one. Fortunately, there's a way around that, which is what I did in the video looking at still from Bobby Shafto's video, which is that you move this to line up with features in the photograph or the video anyway, so it doesn't really matter where it is relative to that calculated eye level. It matters where the features in it are relative to each other. So you would take the separate, just the green geometric lines, which is this shape, or just the blue flat prediction lines, which is this shape. Notice they are both curved across the top. They do both pretty much point straight at the vanishing point down there. And you would overlay one on top of the other. And that gives you this. Great. Hello. Whatever. Great thing about using GIMP to draw these, you can just put the layers in dark and only mode. So slightly weird foreground up there, but everywhere else, it's possible I goofed up there and put things in the wrong place. Everywhere else you've got blue dark and only on top of green, dark and only on top of white background, adds up to black. Black pixels like that is where they are in exactly the same place to the nearest pixel, where the tangent of the angle is the same to 4 decimal places. Now, the tangent of the angle being the same to 4 decimal places may not mean much to some people. The fact that it's showing up as black in most places suggests they are the same in most places, at least at this distance. This is quite a short distance, of course. Way down here, you can see that they are not lined up, that the flat prediction is higher than the globe prediction. Way down here, you can see how, in the bottom right, this one that's, camera was at 100 meters. Everything up there at the top is at 125. This is at 95. So this is some really tall light poles in a car park with maybe small car only parking. And this one is 5 meters below you. So this is as if you're looking out of an upstairs window. This would be a line along the ground. And at this distance here, where we've gone past about half a mile away, getting on for 3/4 of a mile away, I did continue it out to about 2 kilometers. They are just 1 pixel different, which is the 4th decimal place in the tangent of the vertical angle. What does that signify? Well, rather than saying the 4th decimal place in the tangent of the angle, I included a figure for scale, this right here. This is the silhouette of a famous 6-foot-tall lady whose name I have already forgotten. But yeah, those 15 pixels, that's 6 feet. And isn't quite lined up because I used one of the closer lines to get the line up. Obviously, I could line her up on herself there and get more of a difference close up and less of a difference at that distance. But anyway, the amount of difference geometric with no refraction curve versus flat makes at a mere 3/4 of a mile is 1/15 of the height of this 6 foot, well, approximately 1/15, somewhere between, what would that be? Somewhere between a 30th and a 7.5, approximately 1/15 of the height of our famous 6-foot-tall lady. And that is why it is so much better, in my opinion, to use the distant mountains, whose relative positions in the picture actually do show you whether it's flat or curved. Well, they show you that it's curved, rather than trying to get down to like a few inches difference at 15, 6 foot, 72 inches, so it would be 4 2/3 inches at 3/4 of a mile. That's easy to lose in haze and low resolution and stuff. The whole of Mount Rainier being below North Sister when seen from South Sister, that's a bit more obvious. And that's why I use mountains.